Hi, I'm Dr. Rani Pavithran. We shall see what is an electrochemical series. Electrochemical series is also called activity series. It's an arrangement of elements, especially metals, in the increasing order of their standard electrode potential values. That means metals are arranged in the increasing order of their activity or decreasing order of their activity, that is either increasing order or decreasing order. That means standard electrode potential values will be of these metals will be arranged. The metals will be arranged in the increasing order of standard electrode potential values. Standard electrode potential value means it is always the reduction potential, standard reduction potential values. So in this arrangement, the elements are arranged in the increasing order of their standard reduction potential values. And also, this standard reduction potential values means they are actually calculated or determined using standard hydrogen electrode as the reference, and this electrode potential of standard hydrogen electrode is taken as 0. Therefore, in an electrochemical series, the standard electrode potential values are on the hydrogen scale. Since in their determination we are using the reference electrode as a standard hydrogen electrode, and which is whose electrode potential value is taken to be equal to 0. Okay, then we can say that in an electrochemical series, the most reactive metals are placed at the top of the series. So the reactivity decreases from top to bottom in an electrochemical series. Now the applications of electrochemical series. First one is we can calculate the standard EMF of the cell from or using electrochemical series. The EMF of the cell can be expressed as E naught cell is equal to E naught of the right electrode minus E naught of the left electrode, or E naught cell is equal to E naught cathode minus E naught anode. So we can directly get the values of E naught of cathode and anode from the electrochemical series, so that we can calculate E naught of the cell or EMF of the cell using electrochemical series. Next application is predicting the feasibility of a cell reaction. For example, you have to see whether the reaction between zinc and copper sulfate will be feasible or not. In order to see whether this reaction is feasible, first of all you have to calculate the EMF of the cell. EMF calculation is possible, as we have already seen from the electrochemical series. So if the calculated value of EMF of the cell is positive, the cell process is said to be feasible, because from thermodynamics the feasibility or spontaneity of a reaction depends on the sign of standard free energy change of the reaction. If the standard free energy change of the reaction is negative, then the reaction becomes, or the process becomes, spontaneous. And there is a relation existing between the standard free energy change and the EMF of the cell, as delta G naught is equal to minus NF E naught cell. Now, if E naught is positive, delta G naught will be negative and the reaction will be spontaneous. Thus, we can identify whether the cell reaction is spontaneous or feasible using electrochemical series. Next application is predicting whether a metal can liberate hydrogen from an acid or by reacting with an acid. That means when a metal reacts with an acid, if we get hydrogen or not can be predicted by using activity series or electrochemical series. For example, you consider the reaction between zinc and sulfuric acid. So in the activity series, zinc is placed above hydrogen in the electrochemical series. That means zinc is more reactive than hydrogen, and zinc has reduction potential values minus 0.76. So it has a tendency to undergo oxidation. That means when zinc is treated with sulfuric acid, zinc can displace hydrogen from sulfuric acid, forming or liberating hydrogen. That means the reaction between sulfuric acid and zinc is possible, and zinc can liberate hydrogen from sulfuric acid. Whereas you consider silver, the reaction between silver and sulfuric acid. silver is placed below hydrogen in the electrochemical series. So silver cannot liberate hydrogen when treated with sulfuric acid. That means we can conclude that in an electrochemical series, a metal placed above hydrogen in the electrochemical series can liberate hydrogen when that metal is treated with an acid, and a metal placed below hydrogen in the electrochemical series cannot displace hydrogen from an acid. So when elements are arranged in the increasing order of their standard reduction potential values in electrochemical series, a metal placed above hydrogen in the electrochemical series can displace hydrogen or liberate hydrogen from an acid, whereas a metal placed below hydrogen in the electrochemical series cannot displace or liberate hydrogen from an acid. Next application is to compare the reactivity of metals. For example, you consider the reaction between zinc and copper sulfate. That is, you have to see whether zinc can react with copper sulfate, or zinc can displace copper from copper sulfate solution. Displacing copper from copper sulfate means zinc has to react with copper sulfate, forming zinc sulfate and copper. Is that reaction possible, or is zinc more reactive than copper? So in order to explain this reaction also, we have to see the position of zinc and copper in the electrochemical series, that's all. So zinc is placed above copper in the electrochemical series, so it's clear that zinc can react with copper sulfate, forming zinc sulfate and copper. That means zinc will undergo oxidation to form Zn2 plus, copper will undergo reduction to form copper. Copper will be deposited on the surface of zinc. So thus we can say that zinc is more reactive than copper, because zinc is placed, or zinc lies above copper in the electrochemical series. Then you consider another reaction, reaction between copper and silver nitrate, whether it is possible, or which is more reactive, copper or silver. Okay, then we know from the electrochemical series, or we can see from the electrochemical series, that copper is placed above silver in the electrochemical series. So copper can react with silver nitrate, forming copper nitrate and silver, because copper is lying above silver in the electrochemical series. That means a metal A, for example a metal A lying above in the series can displace a metal B, okay, lying below A in the series from the solution of B. For example, if A combines with Bx, you will get Ax and B if A is lying above B in the electrochemical series. Thus, the electrochemical series is an arrangement of metals or elements in the increasing order of their standard reduction potential values. Okay. In this arrangement, most reactive metals are placed at the top of the series. Then the reactivity of metals decreases down the series. Okay. Then a metal can liberate hydrogen from an acid if the metal is placed above hydrogen in the series, and a metal placed above hydrogen, or a metal lying above a second metal in the series can displace the second metal from the solution of the second metal. Thank you.